Hello Nerf fans, Spectre N7 here. Today I'm going to be showing you how to build a Category 5 Hurricane. This is the worker Hurricane. Currently this is completely stock, nothing's been done to it. And what we're going to do is we're going to add this two-stage flywheel cage created by Meishel of FoamBlast. We're also going to add this 3D printed extended grip. We're going to be adding the worker black replacement flywheels, and we're going to be putting 4 Kraken motors into this thing, because that means I can run it on 3S, and if I run it on a lithium high voltage battery I'll get about 160 feet per second out of it, which is not bad at all really. So first things first, we need to crack this bad boy open. Now I'm going to be reusing this switch, and I'm going to be doing a MOSFET loom for this, but pretty much all of this can just go. So the only thing, as I say, that we're keeping is this switch. All of that can just go. So now what we have is the shell of the Hurricane. Now this is where the motors rest for the existing cage, and one of the things that we're going to have to do with this is we are going to have to shave back a chunk of this, because once you've put the flywheels into there, they will just about run fine on that barrel, but we have to shave out all of this space. So we just ruined that camera shot. All of this area here, so these are going to get cut off, and all of this area here we have to shave down so that the shell, and I'm hoping you can see this, so that the shell, all of this bit here, needs to be lower down up to that. Now I'm going to use a Dremel to do that, and I'm not going to make you sit and watch all of that, so I'm going to basically go to work and do that, and then show you guys some YouTube magic. Okay, so I'm hoping now you guys can see the shaving work that's been done there. So this whole area here has now been shaved down, and you should hopefully, I don't know if the camera can pick this up, but you can see when you hold this up to the light that we've got a whole bunch of pattern. You have to be very careful when you do this, because if you go on for this for too long, you can actually go through this. You can go through this, or worse, you can actually heat this up to the point where the shell melts, because you are getting this down very fine. So this is one that I did earlier, and this is my personal one. So I'm not hugely happy with that, but I'm going to turn it into battle damage. But that's what happens when you go too long at this. You have to take it in short bursts, or just be careful with it, just to make sure that you don't go through the shell. But this is just making space for the for where the wiring and the motor tabs are going to go. This has mostly been done using a Dremel tool. So just to give you guys an idea of what I'm doing here, taking the Dremel, just using the height from here, as you guys. Now obviously I'm not finished there, but what you can see is I've taken, again, just this kind of, trying to get it down to the same level here as all of this space is here. So where the original motors were spaced, where the original motor sort of indent was, we're just trying to make enough space for the flywheel cage to cover all of that space. We've also taken a small rim across the top of here, so that when you put the flywheel cage into position, so just trying to make sure he gets it the right way up, there's just enough of a dip that there's no risk of the second flywheel cage rubbing on the barrel mount. Now you can look at mounting this faux barrel for, again, this is the worker faux barrel kit for this. You can look at mounting that here. I haven't found that necessary, and honestly I would be worried about the dart alignment, and honestly you don't need it, but it is an option. I'm going to go back to cutting the rest of this, and I will then start showing you how we install the wiring into this thing. So this is the cage mount. It actually sort of sits that way up in the actual blaster. Just like any other cage, you want to mount it so you've got your red dots opposite way around, and that way you know your flywheels are going to spin in the correct direction with the correct orientation. What we're going to do first of all is I'm going to dig out my Loctite, and we're going to use these tiny little motor screws just to screw these into place. These all come with the Cat 5 cage, which is super awesome, I feel. Just means that you know that your motors aren't going to go anywhere, your screws aren't going to go anywhere. Pretty much everything that I am using at the moment came together all from out of darts, but I can't recommend this thread locker enough, and particularly when we're going to be running these motors at quite high RPM. We definitely don't want them coming loose, and you're going to get a lot of vibration, and obviously it's a 3D printed cage, so just putting in a hefty blob of blue Loctite just means that we know this we know these motors aren't going to go anywhere. We know that the screws aren't going to come out and gouge big chunks out of your flywheels. When I first put my Jupiter together, I skipped this step, put the screws in, didn't put the Loctite in because I was kind of in a hurry to build it, and about 2/3 of the way through my first game with it, it started to make a horrible noise, and it's because the screw had worked its way loose and carved a massive gouge out of the flywheel. You want to be careful when you're doing this and not do what I've just done and bend the tabs on your motors. We are going to bend the tabs on the motors deliberately later, but we're going to do that to try and minimize the amount of space they take up. But first, we have to apply the flywheels. Now these are quite a tricky flywheel to apply, so I tend to take a heat gun just warm the flywheel a bit. And as always, when you're applying pressure to a motor, just make sure that you've got your finger or thumb on the bell of the motor, so that when you are pushing down, your motor doesn't go flying back out, so you don't break it. Again, it's just a matter of applying force. Now this makes this process super easy. If you don't have a heat gun, you can do it with a hairdryer, or you can put them in warm water for like 10 seconds, but make sure it's not too hot. Because again, we're just looking for a nice easy application without them coming loose and without breaking the motor. Because if you put them in for too long, then you risk melting the flywheel and them coming out of true. I really should probably stop trying to do narration with the air gun on. If you leave them on and get them too hot, then obviously that can damage the flywheel, so there's a balance to be found. Now there are 3D printed kind of things and tools you can get, and I think FoamBlast do a flywheel fitting tool, which makes this, you know, also pretty easy, and it just means that you can't possibly screw it up. And while that's nice and all, it's not actually that necessary. Just making sure that's all the way down, because otherwise that's going to cause me problems later. There we go. So that's your flywheel cage with the motors applied. Again, just making sure that you've got your dots on opposite sides. Now I tend to wire these positive to the front and negative to the back. Now because it's a dual stage flywheel cage, and because of the way this is set up, I'm going to be wiring this slightly differently, and I'm going to come on to that later in the build. All the shell cutting's been done, all the shell shaving's been done. So, oh wait, no, not all of it. So I'm going to very quickly just show you some stuff. So in here, there are normally 3 posts, which are the mounting point for this half of the cage. In order to get a slightly wider dart mouth and a smoother finish through, because obviously this curve here causes a problem, just basically to place this slightly further out, what I've done is I've cut down these posts, and you have to cut off this edge here. Okay, so there's like a lip here that you have to cut off, and there's a lip here that you have to cut off and sand. So that's the way that it fits in. So you've cut off this lip here, and you've cut off this lip at the bottom here. So this now basically rests against the back wall of the shell. Now my solution here is generally to just glue it into place, frankly, and that's what I'm going to do. So I'm going to find my clippers and just do the last little bit of this, because that's still causing problems. Now you see that fits flush. So we just grab our trusty Gorilla Super Glue. This is a nice CA glue, and we just run a line of glue along that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we just push that in there, and we push it down hard, so again we get that nice, and we just basically count until that's dry, which is normally about 30 seconds. Now, with this one, we've done similar. We've kind of wired all this down. Now, the next stage of this is going to be wiring it all together. We've done all the shell cutting, apart from this last piece, because we're going to be making enough, so we need all the space we can get inside this grip. So we're just going to use our side cutters to get these out. Just get them all the way out, make a nice bit of space for our 3S battery. And again, just take a little bit of sandpaper and just smooth those edges down, so you don't catch anything we don't want them to. Now, the flywheel cage is going to sit in there. Now, because of this bit here, this sort of barrel guide mount, the cage has to be wired slightly differently. So what we're going to do is we're going to use our trusty MOSFET diagram, and we're going to wire this all together. But we're going to wire, instead of wiring across here, we're going to wire negative, or sorry, these are the two positive terminals. So we're going to wire this positive to this positive, and this positive to this positive, and then these two positives together, and this negative together, and then this terminal to this terminal. So what you end up with is like two lines of wires coming across here, and that will show you, and that means that you don't get wires crossing this bit, which is where your dart needs to go, and where your, not where your dart needs to go, don't talk rubbish Spectre, but where this bit needs to go. So if you can't have wires crossing these two motor poles because of this plastic bit. You could remove that, but it's quite, I think it's kind of useful to have from a structural perspective. It keeps the cage aligned properly. So this sort of solution solves that for you. I'm going to, again, basically cut now, and I will then show you this when it's finished. So I'm just going to talk real quickly about the offhand side of the shell. We've talked a fair bit about the primary side of the shell, which obviously with all the shaving and the wiring and everything else, that's the one that we mostly do all the work in. But there's a fair bit of work that you need to also do on this side of the shell. As we've talked about, and as I've shown you earlier on in the segment, we've talked about how we need to adjust the cage half. But you also need to make sure that you take this bit here, this sort of faux barrel mount, and that you also cut that back and sand that back so that there is space for the flywheels to rotate on the second stage, because if you don't, then the flywheels will jam and your motors will burn out. So do make sure that you cut those back as far as you can, as far as you need to. Test fit and test fit and test fit again. Make sure you don't burn your motors out. This is obviously quite a complex build, and it is something you need to take a fair amount of care on. Okay, so now we're going to talk about wiring. Been taking me a little bit of time, but this is now all wired together. This is because this switch is really, it's not really designed for the kind of amperages that we're going to be putting through it. I have used a MOSFET in order to keep the current out of the switch. Now, this is a 3034 MOSFET because it needs to be high enough to take the current of the circuit. We've got 4 Krakens in this. Well, as we've discussed, we've got a fairly hefty stall current to deal with. Now the video that I use for this and how I learned about MOSFETs has been through Foam Data Services, and there's an excellent video that he's put together about how they work and how they operate. I'm going to put a link to that in the description. I'm not going to waste time talking about MOSFETs because he does a way better job of it than I would do. But what I've done is, the only thing to bear in mind is that because of the way that the Hurricane works, when he's talking about wiring to the normally open, you need to wire to the normally closed on the switch, which is this one here. So that's because when the trigger is not pressed, it's depressing the switch, and as soon as you pull the trigger it releases the switch, and then that's when you want current to flow. So you need it to be running to the normally closed, not the normally open. So this is nice and simple. It's running all the way back into here, and all the wiring is nice and tidy. That's the wiring setup that we've talked about for the... You can wait for the camera to stop shaking. This is the wiring setup that we've talked about. Now, in particular with this one, it's really, really important that you make sure that you heat shrink all of these joints, because this is going to get pressed down really quite tightly against the shell. And if you don't, if you get shorts between the motors and the cans, you will short out your MOSFET and set your light bulb on fire, and that's bad. So do make sure when you're doing this, I'm going to probably take a little bit more time and just spend making sure that that's all the way through. But you can see I've also made sure that I've got heat shrink on all of these joints, making sure these are all nicely covered so that there's no way that we're going to get any kind of short across these. These two joints here are where I'm going to be wiring in the main loom, and I will heat shrink those once I've done that. I'm hoping that this all comes through together. I'm going to now put it all together and you guys will hopefully get to see it. So yeah, so you've got your, obviously you've got all the MOSFET stuff going through the main loom, coming off to an XT60 connector. Should be relatively straightforward to put together now. And then that will be the last thing for you guys to see. But hopefully that gives you some idea of how you go about putting together a Cat 5 Hurricane.